This is the homework for 865 and 866. In problem 865, you need to expand each expression into factor form, then rewrite it in simplified exponent form. So we have 2 to the 4th power multiplied by 2 to the 2nd power. So here's the factored form. 2 to the 4th power is 2 multiplied by 2, multiplied by 2, multiplied by 2. And 2 to the 2nd power is 2 times 2. Well, you can see that we have 2 divided by 2 and 2 divided by 2. This creates a big 1, a big 1. So 1 multiplied by 1 is just 1, and then 1 multiplied by 2 is 2, multiplied by 2 is 4. So these we can cancel out, and we have 2 multiplied by 2, which is 4. The other way of doing it, not in the factored form, by not factoring it, but doing 2 to the 4th minus 2 to the 2nd, because that's essentially what we're doing. We have 4 2's here, the product of 4 2's, and then we're going to take away 2 of them from here, and we're left with 2. So 2 to the 4th minus 2, and that's where we get these 2 by creating big ones, equals 2 to the 2nd, which equals 4. In problem B, I did not put it in factored form, but to solve it by factored form, you would have 3 to the 4th, so 3 times 3 times 3 times 3 over 3 to the 5th, so you would have 5 3's. And what you would be doing is you'd have 3 to the 4th, and then you would be taking away, subtracting 5 of them, which would give us a negative 1. And remember, if you have, you don't want to leave it as a negative exponent. So we're going to take the reciprocal of this, and when you take the reciprocal of 3 to the negative 1st, it will go down to the denominator, and it'll eliminate the negative exponent. So you would have 1 over 3 to the 1st, or 1 over 3. For C, we have y to the 7th over y to the 4th. So we have 7 y's in the numerator and 4 y's in the denominator. So 4 of these y's would create 0 pairs, so it's 7, not 0 pairs, but giant ones. 7 minus 4, which will give us 3. So it's y to the 3rd. In D, I started by putting it in factored form. So x to the 3rd is x times x times x, multiplied by y to the 2nd, y times y, over y to the 1st times y to the 2nd. And if you don't have an exponent there, you can put a 1 there, because it's x to the 1st is just x, and we have 1x there. So now here's a big 1, x divided by x is 1, and here y divided by y is 1, y divided by y is 1. So those eliminate for identity property multiplication. Anything multiplied by 1 is itself. And then we have x times x, which is x squared. And remember, x times x is not 2x. Think of having 1's here, same base, and when you're multiplying terms with the same base, they're exponents, you just add them. 1 plus 1 is 2. I could have also just subtracted the exponents with the same base. X to the 3rd minus x to the 1st. X to the 3rd minus x to the 1st. I like to pretend like this is a subtraction sign to remind me that I'm subtracting the exponents. So treat the fraction bar like a subtraction sign. 3 minus 1, 3 minus 1. 2 minus 2, because these have the same bases. So 3 minus 1 is 2. 2 minus 2 is 0. anything to the 0 power is going to be 1. So we have x squared multiplied by 1, which is x squared. For problem 866, we need to simplify the expression. So here I have 3 to the second power divided by 3, which could be 3 to the first power. So 3 to the second power minus 1 is going to be 1, 3 to the first power. 3 to the third power minus 3 to the third power, which is here, equals 0. So that's 5 to the 0 power. And then 8 divided by 8 equals 1. Or if you want to do the exponents, 8 to the first divided by 8 to the first. So that's 1 minus 1, which also equals 0. And anything to the 0 power equals 1. So we have 3 to the first, which equals 3, times 1, which is 3, times 1 is 3. In problem B, you have to remember that when you have parentheses, think of them as grouping symbols. And everything in this group will be affected by this 4, this exponent. So this 4 applies to everything in this group, not just the x, not just the 3. So we're going to distribute this exponent, and I put 3 to the first, because remember when you a power raised to a power, the rule is that you multiply. So 4 multiplied by 1 is 4. So you keep the base, and a power raised to the power, you multiply the exponents. So 1 times 4 is 4. Then we distribute to the second term, and it's x to the first multiplied by 4 is 4. You don't just do it to one term. You can't just do it to the 3, or you can't just do it to the x. You have to do it to each term. It's everything within the parentheses. Now we don't have like terms, so we can't combine these. But we can simplify 3 to the 4th. And I would like to simplify anything that has a power of 4 and less. If it's 5 or greater, leave it in exponent form. So I have 3 to the 4th power, which is 3 times 3 is 9, times 3 is 27, times 3 is 81, x to the 4th. In problem C, we have 3 to the 8th multiplied by 1/3 squared. So I'm going to write 3 to the 8th as a ratio over 1, and you'll see why in a moment, because I'm going to distribute this exponent to the numerator and the denominator. Just like in the previous problem, you had to do it to every term. When you have a fraction, you have to do it to both parts, the numerator and the denominator. So again, we can have an exponent here, 1 to the first power and 3 to the first power. So, and when you have a power raised to a power, you multiply them. So 1 multiplied by 2 is 2. So it's 1 to the second power. And then now we have to distribute to the denominator, keep the base, and then you multiply the exponents. 1 multiplied by 2 is 2. And I always like to remind myself, if I have a parenthesis here and I have a number right next to it, next to the parenthesis, that reminds me to multiply. So I'm multiplying those exponents. Now you can, I have 1 to the second power, which equals 1, and then 3 to the second power. I'm not going to simplify this yet, and you'll see why. Now I have 3 to the 8th over 1 multiplied by 1 over 3 to the second. And this is why I have this as written as a ratio over 1, because I have 3 to the 8th multiplied by 1 equals 3 to the 8th. 1 multiplied by 3 to the second is 3 to the second. And now you can see that we have like bases, 3 and 3, and we're dividing these integer exponents So 3 to the 8th and 3 to the 2nd, if you have the same base, the exponents you subtract. So here we have 3 to the 8th over 3 to the 2nd, and that's 8 minus 2. Keep the base, subtract the exponents when you're dividing, which is 3 to the 6th. I'm not going to simplify this because it's 5 or higher, so I leave it as 3 to the 6th. In problem D, I have 7 to the 4th multiplied by 9 squared over 9 to the 3rd multiplied by 7 squared. Now, it doesn't matter that base 7 is here, and 9's here, and 9's here, and 7's here. Because of commutative property of multiplication, I could move these around, and I could have 9 halves over 9 thirds. So I can simplify this, and I can also do that with the 7's, same base. And remember, when you're dividing integer exponents with the same base, the rule is that you subtract the exponents. So keep the base, which is 7, and then 4 minus 2. 4 minus 2, which will give me 2. And then 9 squared minus 9 to the 3rd, so we keep the base, 9, and then 2 minus 3. 2 minus 3. Well, 2 minus 3 is negative 1. And so you can't have a negative exponent. So remember, you take the reciprocal of this. So we have 7 squared, which is 49. The reciprocal of 9 to the negative 1st is 1 over 9 to the 1st, or 1/9. And now I multiply 49 multiplied by 1 is 49. And then if I were to turn this into a fraction over 1, 1 multiplied by 9 is 9. So we have 49 ninths.